A new day, a new project. This is part 2 of the solar power diverter. So I found a transformer, the one right here. I just connected to the mains and let's check it out. Let's see what kind of voltages do we have here, what we need for the project. 16 volts here, 16 volts over here. Okay, so this is perfect. This is exactly what we need by the schematic. So this is exactly what we need to have 2 times 12 volts. All I have to do now is to connect these things together. We got the power supply, we got the transformer, and we should have here plus minus 12 volts. Let's see. 11.9, 13.2. So that shouldn't be a problem. It's 1 volt difference between. Anyway, I'm pretty sure it's working like that. Now I have to connect the board. Remember this one? Okay, so we have power. And let's see what is happening if I turn on the light. Bam bam. And what about? Now we are faking a kind of signal over there. So that's a proof that the system is working. And let's see some signals here. Let's have a visualization of the signals. A sinusoidal signal straight from the transformer. There we go. 21 volts. Okay. Then the signal goes to the half of Lm on pin 5. So on pin 5 we have a sinusoidal, a little bit of limiting. Then the output of the first one, we should have a kind of square, and that's pin number 7. 1, 2, 5, 6, 7. Here we go. And you see that's a perfect, almost perfect square over there. The other one, now it's in the air, but it's on pin 1, so the coil is working. Very nice. Now let's see the output on the IC number 4. That's the output over here. And there we have this square signal 2. That's the output. And let's see if we have any kind of happening. If I move this, no. But anyway, there's nothing much to do now. You see the signal over there? So we have this square, almost square. If we do like this, you see the signal variation. The next step is to have a proper setup, and I'm gonna put my inverter to work and to see if it's really going and diverting the things. And instead of this diode over here, this LED, I think I have to put a relay. I can say the schematic it's working as it should, and I was trying to have a relay here in the output of the schematic. Unfortunately, a relay is not working because we have this kind of situation. It's always a kind of alternative current over here. You see, now I'm faking a kind of signal. The electronic is working. You see that? You know, because we are mostly water, I may say, our body is like a huge antenna. So our body is collecting all the electromagnetic fields around us, and somehow you turn yourself in a 50 hertz signal generator. It's that hum, I may call it. It's like brrr, a frequency of 50 hertz, and exactly what I need, because now I'm faking the entrance here, and you see the electronic is reacting very well. So this is equivalent somehow with a kind of current through the coil. This is okay, but you see, because of this alternative component, the relay it's oscillating. I can stop it, you see. Now it's a situation, let's say, when the inverter is exporting current. I tried many other possibilities and many other ways to do this. I'm afraid we have to use that kind of high voltage transistor here, because the load will have a kind of this almost sinusoidal, but with different amplitudes. Depends of the power delivered by the inverter. So the load should be a kind of I don't know, bulb or a heater. It can be a power supply for let's say for charging batteries or something, because this switching power supply, they can adapt to the power delivered, you know, this kind of you know, they are working from 110 to 230 volts. So it doesn't really matter, because all the switching power supply, they have a bridge in the input, let's say like this. So we have AC over here, and then we have plus and minus, let's say, and then we have a huge electrolytic capacitor. So that's the main over here. Doesn't really matter what's the signal over here, because a power supply, it can work also with that kind of modifying sinus from inverters and any kind of waveforms, as long as it's 50 or 60 hertz in. So this is our situation. Okay, so for now, all I can say is that the electronic is working as it should. Let's say now we have a situation when we are importing from the grid, and if we doing like this, we have a situation when the inverter is exporting only, and now it's exporting. Somehow it's working, because now we have no power to the relay. You can hear that, and if I check the contacts, they are closed. I mean, switch off. And I'm afraid that's it for now. I don't have that kind of power transistor, because it's pretty special. It's for high voltages and high power and so on. And then we need this kind of bridge. But anyway, as soon as I'm going to have the parts, I'm going to finish this, and I'll do the right experiment with the right inverter. But in the meantime, by the way, let me see the waveform at the entrance of the relay. So we have the ground here, and I have the signal over here. We have a signal like kind of square. It's almost looking like a kind of pulse width modulation. And let's fake, we have import now. There is almost no load. Then if we have export, everything turns upside down. And it's connecting the load. It's almost a square wave over here for balancing the input. Okay, thank you very much for now. As soon as I'm gonna have the right parts, I'm gonna do a final test about this. Anyway, I can say that the schematic is working, the idea is right, and it shouldn't be a problem to have the final setup. New projects coming soon. In the meantime, be safe. Bye bye.